I guess with that, I'll get going. I'd like to introduce myself as well, but I don't think I can possibly beat that introduction. Drew Demokis, technical specialist with Unity Solutions, and I also have my email address on there as well. If any questions need to be followed up on in any greater detail, please feel free to hit me up at drew.demokis@unity3d.com. And anyway, today I'm just going to be giving a brief overview of Unity's XR roadmap. So we're going to touch on a variety of different topics, from XR architecture that's being built within the editor and engine itself, and some of the different things that'll enable from the development side, like AR Foundation and the XR Interaction Toolkit. We're also going to talk about how we're evolving our rendering technology with a scriptable render pipeline, and we'll touch on Unity Mars, which is an editor-specific tool meant for authoring augmented reality. Then we'll finish up just by examining how Unity is empowering the future and taking a look at some use cases we're seeing outside of the gaming space. So let's start by looking at some XR platforms as well as new XR platform architecture. So today, Unity supports all major AR VR platforms that you can see listed here. And something that we've noticed is there's a lot of different platforms, but they're being updated and released at an accelerated pace. And at Unity, we want to make sure that we can provide support for the platform, enable all these features, and enable developers to be successful when building for these different platforms. So what are we doing? Some of the things that we're doing, we're basically providing what we call the XR provider layer. This is a standardized set of APIs for each specific platform. So you're seeing the subsystems specifically for ARKit. Then we have the developer layer, and this is what you as a developer can actually access. It's a kind of an abstraction on top of the platforms themselves, where we feed in data from all the different platforms into this unified layer. What this ends up looking like on the Unity side is that we're using packages. So we have a new built-in package manager, and this allows us to distribute these platform integrations at a more accelerated rate and outside of the core editor release themselves. So this includes the ARKit package, the Oculus package, and others. And this is where all of these abstractions and developer layers get exposed. So what does this enable? Well, one of the big things we've been working on is AR Foundation. This is Unity's augmented reality SDK for multi-platform AR experiences. Now, what this looks like is that it's enabled through the different packages. So on the mobile side, we have AR Core and ARKit package. Then we have the AR Foundation package. The way the packages work in Unity is that different package versions are verified with different versions of Unity. So you can see that for 2019, which is the latest LTS version of the editor, we have the verified version of 2.1.8. And for the latest and greatest features, you're going to want to use the latest version, which in this case is the 4.1 preview version of AR Foundation. And the nice thing about the way the packages are structured is we actually have the packages verified for later versions, but they're still compatible with the earlier versions. So if you wanted to use the latest features from the 4.1 preview, it's compatible with 2019.4, but hasn't yet been verified. So things will still work without necessarily being verified. And by verified, I mean being run through the whole QA suite and checked with these specific versions of Unity. So really, this is what the structure looks like, where we have all the platform packages. Here we have the Windows MR package for things like HoloLens, different mobile devices, also Magic Leap. All of these packages feed data into AR Foundation. And what we try to enable is build once, deploy anywhere. So you as a developer can build your application in Unity, and then depending on what platform you build to, we hook up this logic and decide which package to integrate into the application itself. For example, if you build for iOS, you'll get the ARKit package. And if you build for UWP, you'll get the Windows MR package. And what this looks like is it allows you to have the exact same applications running on different platforms. So on the left, there's a screenshot from an Android application, just a simple app where you can find and place spheres. And we have the same thing on the right running on an iPad. So let's take a look at some of the latest features we've added to AR Foundation. There's a depth image API. This was released by both Apple and Google and allows you to return a depth image from the device itself. So there's some limitations surrounding which device it'll work on, but really it'll give you a deeper understanding of the environment and allow you to do things like occlusion and other computer vision techniques. The latest ARKit 4.0 features are also enabled. So this is available in iOS 14 beta. It includes things like meshing and also has that depth API that I just mentioned. And last but not least, here we have the camera image API. This is something we've done to allow developers to access the camera image on, say, a mobile device on the CPU side. So you don't have to pass the image between the CPU and GPU if you're doing something like custom computer vision algorithms against the image. So when AR Foundation started, it was really just focused on these mobile platforms. More recently, we've added these head-mounted platforms as well. And while every feature isn't necessarily available on every platform, we're continuing to add features from the Microsoft HoloLens and Magic Leap into AR Foundation and enabling those for developers. For example, ARKit recently added the meshing API with the LiDAR-enabled devices, and the Microsoft HoloLens had this meshing API for some time. So we're kind of combining those, filtering out the data, and giving developers the ability to interact just with the AR mesh and not worry about the platforms. Of course, just quickly, if you're not familiar, Magic Leap builds a standalone AR headset. Microsoft does as well with the HoloLens 1 and 2. And at Unity, we tend to think of the HoloLens as a platform in itself. So a lot of the features I'm talking about will work for both the HoloLens 1 and 2. And really what you get is you're able to do the exact same content, similar to the Android and iPad example. So on the left, we have a screen grab from a head-mounted device, and we're still going around scanning different surfaces and placing objects on them. And the big difference you're going to see here is that on the mobile side, you're able to just tap the screen to place assets. But on the HMD side, you require some form of hand tracking, gesture recognition in order to place all those assets in the world. If you're interested in getting started with AR Foundation, I recommend checking out these sample repositories. At the Unity GitHub at Unity-Technologies, we have the AR Foundation-samples. That's really an implementation of all of these different features that are enabled in a very kind of simplistic way. We also have AR Foundation-demos. This is where you'll find more polished content with things like onboarding UX, image tracking, depth, all within a more polished framework to allow you to make high-quality AR content. Oh, pardon me. The next subject I wanted to touch on briefly is the XR Interaction Toolkit. This is a base framework that we're providing at Unity that enables a lot of base functionality in AR and VR applications. So we have things like being able to place content, scale it, move it, and rotate it in mobile AR. We have a lot of these things for VR, like being able to do different teleport locomotions, physics objects, and interact natively with the Unity UI. The example you're seeing here on the right here is just a small example where you can pick up this llama, and with some input, you can make bubbles appear out of his mouth. It's looking at these more complex interactions, but providing a base level of interactivity. And if you're interested in the XR Interaction Toolkit, there's a VR beginner project on our education platform that introduces users to VR design on all of the high-end VR devices in Oculus Quest. So on the left, you can see the more stylized scene of the escape room. And on the right, you can see another scene where we provide more realistic objects. And you can see how you can add interactivity to things like a drill bit or an hourglass. Really, we're providing both sides of what's possible and giving you some samples to build off of and learn to use the interaction toolkit on the VR side. So the next thing I want to talk about is the scriptable render pipelines. These are ways for Unity to update and modernize its rendering technology. So one of the great strengths of Unity is that we support so many different platforms. But the problem with that is sometimes as the platforms continue to grow, we have to make some compromises. With the scriptable rendering pipeline, we're really opening up what's possible and opening up an entire render pipeline to be modified and changed depending on which platforms you're targeting and depending on the use case. So on the wider support range, we have the universal render pipeline. This is available in a package and it enables high quality rendering on both the AR and VR side. What you're seeing here is a GIF of a VFX graph, which is a unique feature to the scriptable render pipelines, and we're seeing it here placed in augmented reality. So out of the box, we're seeing things like a 25% increase in performance, and really this is the result of using more modern graphical techniques for enabling both AR and VR. And with the universal render pipeline, we're covering all the platforms from mobile to high-end. Now, if you're looking for really high-end or realistic graphics, we have the HD. That's what you're seeing here, and it's only enabled on high-end PCs and consoles. So things like PS4 or Xbox on the gaming side, but on the VR side, we're looking at desktop virtual reality. So it's not available on any of the standalone devices. But it gives you all these modern advanced techniques like volumetrics, screen space, reflections, as well as access to different features like the VFX graph and others. We've added a handful of different samples. This one is a 3D reconstructed model of Unity's London office. And you can see someone moving their head around in there, moving through the virtual space. And you can also kind of take in all the realistic textures, lighting, and things like that. This has officially been verified with Unity 2019.4. use, with the only caveat being that it's fairly expensive, so you may need to pick and choose which features you're running, as well as making sure you have a high-end machine to run it on. Next up, I want to talk about Unity Mars. This is a toolset specifically built for building augmented and mixed reality content within the Unity editor itself. So the way it looks is it's actually an editor extension or editor tool. So here we have it. You can see there are custom panels. And one of the big features that it offers is the simulation and device view. This allows you to simulate and test your content within the editor, so you don't have to build out to your device. It has a few different means of how the content appears and how users interact with it as well. So an example of that are proxy-based workflows. So proxies in this case would represent real-world objects that will be within the environment where you're using your XR device. It also has this idea of fuzzy authoring, which is the concept of setting up different rules and conditions for how your content appears within the world. So you could set up a rule like, if I find a surface that's 1 meter off the ground and 0.5 meter wide, I want this piece of content there. If I find another surface that's understood to be the floor, I want another type of content there. So it's really looking at this kind of procedural authoring, and how they can take that different rules and understanding and have that all work in a variety of different environments. And finally here, this acronym, we have what you see is what you get authoring, where it allows you to do a lot of drag and drop and hook up different components, while also being extendable. So you can continue to write code and custom logic for your specific use cases. So earlier I mentioned different 3D reconstructed environments. So here we have some of the environments that ship within the editor. You can also test at different scales and locations. And the nice thing about these environments is you can also build your own simulated environments. So say you're looking at targeting a specific factory, that's possible alongside the Unity Mars platform. And if you're interested in Unity Mars, I recommend checking out the product page at unity3d.com/products/unity-mars. So just to wrap up, I just want to talk about some of the practical use cases we're seeing outside of the gaming space. And it's really talking about how XR is changing the way we work. Here in photographed, we have a visualization of Unity Reflect. And this allows you to link up directly with applications like Revit to bring in the different metadata and models here, live synced between different versions of those applications. So as you can imagine, at Unity, we're seeing a lot of different tech trends. Remote rendering, easy authoring, enterprise experiences, location-based entertainment, and just so much more. As we continue to listen to our customers and see these technology trends, we're looking at how we can enable developers to take advantage of some of these trends, as well as give them opportunities based on the toolset we provide. And when you start to look at different industries like automotive and transportation, we're seeing lots of use cases for Unity for these early stage programs. So thinking about doing design iterations remotely, where we can visualize the car in collaborative sessions with other remote workers. Another major use case is, of course, training. Huge opportunities here, as you all well know, where you can save lots of time and money by training employees in a virtual environment. And then on the consumer side, consumers simply want to visualize their purchases more and more to get confidence in what they're actually buying. Now onto the media and entertainment side, we're seeing use cases in pre-production, so pre-visualization of how content might look, testing out different animations, camera angles, and things like that. And of course, there's virtual production using AR, VR technology to track motion and build virtual sets. And we also have motion capture, which includes face and body tracking, all to capture performances within AR technologies and then bring those back into the production pipeline. And finally, we have architecture, engineering, and construction. So here we're looking at linking directly to CAD modeling tools. So that's things like Unity Reflect, where you can see multiple users are in Revit, and all of the changes being made are live synced to the iPad Viewer app. We're also seeing use cases in visualizing models, so seeing different stages of how models are built. I like this example in particular because it's being projected down onto the top of a blueprint. And lastly, we have on-site information. So bringing AR and VR devices onto, say, a construction site and being able to see what stage the project is in, as well as just visualizing where things are going to go. This is going to give workers a better understanding of the project and ultimately save time. And yeah, that's about it for my presentation. I'll be available for questions in the chat, and you can also send me an email at the address listed there, drew.demokas@unity3d.com, if there's anything else you'd like to follow up on. And yeah, I think that about does it for me.